This is most of quadratics for a test, right? We'll start off with the easy stuff that we should cover. So this is general form, this is vertex form. Let's go through what the variables mean. So A controls whether the parabola opens up, down, how wide it is, and how narrow it is, right? So if A is positive, that means the parabola opens up. If it's negative, it opens down, right? Now, if A is between 1 and 0, right? That's like how wide it's going to be. Like it works in both negative and positive, and the closer A is to 0, the wider the graph is going to be. While for if it's greater than 1, it's going to become more narrow, more steep, right? Now, the B value doesn't really, like, you won't get tested on that, so it doesn't really matter for now. But the C value, right? That's the y-intercept, right? That's like where the parabola meets the y-intercept, like right there, right? There's only there's only one y-intercept, so you don't really have to worry too much about that. Next, this is vertex form, right? Now, I don't know what variables you have for P and Q, right? But just remember this formula, and whatever variables you're comfortable with, use those. But P is, well, let's start off from the start. On a parabola, right? The middle line that goes right between this, right? And that point right there, that's the highest or lowest, right? Those are the coordinates of P and Q. That's why it's called a vertex point, right? So P is the x-coordinate, so where it is on the x-axis, and then Q is the y-coordinate, where it is on the y-axis, right? Now, make sure to remember that P, like the minus P here, is part of the equation, and to always keep in mind that P is just going to be, to ignore the, the subtraction sign. And yeah, those are the main variables. All right, the next thing that you have to keep in mind are the transformations, and your teachers are going to dock a load of marks if you get these wrong, right? So starting off with the regular parabola, right? Now, if A is negative, right, you're going to say a reflection across the x-axis, and your parabola is going to look like this now, all right? Then, remember the A value, right? If it's greater than 1 or between 1 and 0, right? You're going to want to say a vertical stretch about the x-axis by a factor of A, right? Try not to say compress or anything like that. Just say by a factor of A, whether or not it's greater than 1 or between 1 and 0. All right. Now your graph's going to look something maybe like this. All right. Now you're going to want to say, it doesn't matter, these are interchangeable, but you want to focus on your translations, right? So a horizontal translation, right? That's your P value, all right? So you're going to want to say a horizontal translation, P units to the left or right, depending on it, right? And make sure that you are taking the actual P value and not the P value with the minus sign, right? So let's just say P is positive, right? You're going to, it's positive 3. Let's move it 3 units to the right, 1, 2, 3, and put our parabola there, right? Now you're going to want to say a vertical translation, Q units up or down. Let's say Q is 5, right? So you're going to move it 5 units up. So 1, 2, 3, 4, 5, and right, those are your transformations. Now how to state domain and range in proper notation, right? So you see how this opens down, and the range, or the y value, is always going to be 4 or less than 4, right? So all you want to do is first put range, right? And then the curly little brackets. It's going to be y such that y is less than or equal to 4, and y is an element of all real numbers, right? That's what this part means, and close it off, right? Now for probably all quadratic questions, right? The domain is just going to expand infinitely both ways, right? So all you got to put is domain, right? Squirrely little bracket, right? X such that x is an element of all real numbers, right? And yeah, just ignore that. But that's how you basically put domain. However, if you have a word problem, right, and because it's a real life situation, it cuts off at some point, right? Usually the x-intercept. So you want to put these points as your points. So let's just say this is 1, comma 0, and this is negative 1, comma 0, and this is 5, comma 0, right? You put domain, right, and then squiggly brackets, right? Do a better job at this, by the way. That x is such that it is greater than negative 1, right, but less than 5. And if you had more space, then just comma and put this there, and you should be chilling. That's only for word problems. All right, now I'm going to teach you how to go from vertex form to general form. And this is super easy. Just want to factor everything out, right? So that means just 2x plus 10, and because it's squared, right, x plus 10 again, plus 11. Let's factor this, so that'll be x squared plus 20x plus 100, right? And then plus 11, then multiply everything by the a value, which is going to be 2x squared plus 40x plus 200 plus 11, right? And then yeah, just to finish it off, bring the y down, don't forget about that. Y is equal to 2x squared plus 40x plus 211. Now that's vertex form to general form. Now let's work our way back, right? And this is a little bit harder because we have to do something called completing the square. So first things first, we want to remove the coefficient from the x squared, right? So we can do that by just pulling it out like this, 2x squared. And then we also want to do it for the b value, right? And we got to pull out this as well. So it's just going to be plus 20x plus 211. You see how nothing in this equation has changed value? If I multiply this back out, it's going to be the same equation, right? So we want to follow that same principle and not change the equation's value in any way, right? So next, what we're going to do is we're going to turn this into this, right? And to do that, it's called completing the square, where we want to find a number that, when added together with this, it's going to make a perfect square. But I'll just show you the process. It's easier said than. So 2x squared plus 20x. Now we want to half this and then square it, right? So half of 20 is 10. 10 times 10 is 100 plus 100. But now you see the equation's imbalanced, so I'm going to put minus 100 to balance it out, and plus 210, or 211, right? Next, this part right here, that's a perfect square trinomial, right? However, this is ruining it, so we just got to remove that from this inside part. So we're going to multiply this by this to bring it out, and that would leave us with 2x squared plus 20x plus 100 plus 211 minus 200, which is going to be just 11. Right? And you see how we have 11 up there. Right now, we just got to factor this, right? Now, to do that, just look at these, right? And think of what two numbers multiply to 100 and add to 10, 20, and that's obviously just 10. So you just get 2x plus 10 squared plus 11. You see how we work that out? Make sure to write the y. Now I'm going to show you how to find the roots of your quadratic equation. The roots are where it intersects at the x-axis, or when y equals 0, all right? Now there's 4 main ways of doing this. First, I'd recommend every single time just pull out your calculator and do it on there, all right? I'll show you how to do that real quick. So just press y equals, right? Then put your equation in. Our equation is 2x squared plus 12x, blah, 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 right? So 2x squared plus 12x plus 10. All right, now we're going to graph that. All right. Now you see how the window's like a little off. You can't really see that shit. You're going to want to press window and just increase it. It doesn't really matter, so I'm just going to make that 10, 10, 10, 10. Now graph that. Now we can clearly see our parabola, right? Now just press second trace, then press zeros. Now you want to go left of a 0. So you see how this little pointer thing is left bound of the 0. And press that. Now you want to go right of the 0, right? Or the root. Now it's going to tell you the exact root there. Then if you want to find the one for this one, just clear that. Right? Do the same exact steps, but on that side. Right? However, I need to show you the other methods. First, you could complete the square, which I just showed you how to do. Next, you can factor it, but every single time I just recommend you use the quadratic equation. I'll show you that in a second though. First, let's factor it, because that's pretty easy, especially for something small like this, right? So 2 and 20 have, you know how to factor, hopefully. So this and this is 20, right? So we can turn that into 2x squared plus 2x plus 10x plus 10, plus 10. And yeah, just factoring is just you get the coefficient of this, multiply it by that, and then find the factors of 20, right? And you want to find the factors that add up to this middle value, or the b value, right? And yeah, so 2 and 12 work. You want to split this apart into plus 2 plus this, and this equals this clearly. Then you can just, just split these in half and start factoring these out. So it's going to be, you can factor out a 2x for both of them, 2x, and then you're left with an x plus 1. And on this one, you can factor out a 10. So pull out that 10, and then you're left with an x plus 1. You see how these are the same, right? That's the end goal. So it's just going to be 2x plus 10, and then x plus 1. Now to find the zeros of this, right, is when y equals 0, right? So that means when either one of these equals 0, because we're multiplying them together, those are the roots of the parabola, right? So if this equals 0, then x has to be negative 1. Right, and for this one to be 0, right, x is going to have to be, 2x is going to have to be minus 10. Minus 10 divided by 2 is going to be minus 5. So that means x equals minus 5. Right, and those are the roots of that parabola. Now I'll show you how to do it with the quadratic equation, right? Now, your teacher should provide you with this on a test so you don't have to memorize it. However, it's good to keep in mind. Right? So it's just going to be negative b plus minus the square root of b squared plus 4ac divided by 2a. Now, I just erased the equation, but I'm pretty sure it was 2x squared plus 12x plus 10, hopefully. And then, yeah, just do the equation. So this is the b value, so plug that in there. So it's going to be minus 12b, right? Plus minus, or no, wait, oops, not the b. Plus minus the square root of 144, which is just b squared, plus 4a, which is 2. So times 2, c, which is 10, times 10 over 2a, which is just going to be 4. All right, so now we're just going to simplify that. That's 8, and that's 80, all right? Yep, 80, 0 plus 144. I can't do that in my head, so I'm going to just do that on the calculator. 244. So 12, negative 12 plus minus the square root of 244 over 4. Now let's see if 244 is a perfect square, because that will make our life a lot easier. Second square 244. And it is not. So what we do in a situation like this is we just simplify it a little bit more. So from this, we can definitely pull out a 4, right? So, but to double check, just divide 244 divided by 4. Now that goes through, so that means we can pull out a 2 because it's a square root. And I don't think we can divide it any further, so it would just be 12, negative 12, plus minus this 2, 61. Right, now if we multiply this back in, we'd have to square it, times 4, and that would equal 244 over 4. Now we can simplify that by dividing the 2's, so 6 plus minus square root 1 over 4. Now, all we got to do is calculate it. All right, so just plug that into your calculator. I'm going to do negative 6 plus the square root of 61, enter, divided by, oops, I forgot to make that into a 2. Now, clearly, I think I did something wrong in the middle of that process. However, usually this will work. And yeah, honestly, just trust the quadratic equation. Put your life on it, because these equations take a lot of time and get really complicated, and this is like an easy cheat code. Of course, use your calculator first. Now, on to word problems. So usually you're going to meet 4 different types of word problems. Let's start off with like the projectile type ones, right? So these ones, they're like Stacy throws something from up here, right? 200 meters, right? When will it land onto the ground, right? So essentially it's asking you to find the roots of the parabola, and they'll provide you a quadratic equation for that, all right? So yeah, all you got to do is just use the previous methods I told you to find roots. Just plug it into the equation. Let's say they gave you negative 5t for time, right? Plus 5t plus 10, all right? Now, this is the equation that represents this parabola, right? So let's say Stacy threw a rock 200 meters above the ground. When will it land on the ground, right? And that the arc of the rock is represented by this. All right, then, because this is small and easy, I'm going to just use factoring to factor this shit out. Also, you can just pull out a 5 from this to make it a lot simpler for you. So just 5 minus t squared plus t plus 2. And then it's like 5. Actually, you just cross that out. But yeah, that's just really easy. I don't want to do this right now. Next, main type of... Oh yeah, I forgot to mention, for those ones, make sure you don't use the root on this side or the negative side, because time can't be negative. But yeah, keep that in mind. Next are these like perimeter area word problems, right? And these ones, like, they're slightly confusing, but if you know what to look out for, you can do them consistently, all right? So now I got GPT to make me like a word problem, and it's just the area is 40 meters squared, and the length is 2 more than twice the width. Now you have to find the dimensions of the rectangle, all right? And for this, you just got to remember all of like the equations that you'll need, right? So to find area, right? Area is just length times width, right? It equals 40 meters squared. All right, and now we know that length is equal to 2 times width plus 2, right? So we can just replace that with that, right? So we can get width times 2 width plus 2 is equal to 40 meters squared, right? Now just factor that out, so it would be 2w squared plus 2w equals 40 meters squared. Now, I want you to remember completing the square, and that just makes us a lot easier, all right? So we can just pull out a 2w squared plus w, right? Then remember half of this squared, and it's half the coefficient, by the way. So it would be 1 half of that, which is going to be a half, and then square that, so it's going to be plus 1 over 4 minus 1 over 4, right? Is equal to 40 squared. Next, right, you want to, pull this out. So you're going to go and then that times that, so it's going to be minus 1 half, right? Next, you want to, complete the square, so 2w plus a half squared, and then bring this over to this side, right? So you're going to get is equal to 40 plus a half, or yeah, just 40 plus a half. Then you want to multiply both sides by 2, so you're going to get 80 plus 1, which is just going to be 81, right? Then you have w plus 1 half squared is equal to 81, right? Now, how do you get rid of this squared, right? You can just square root both sides, right? And then boom, that squared's gone, and you just have w plus 1/2, right? And you see here how this is a perfect square, which is pretty convenient, so we can just write that as 9. And also, make sure, have plus minus. I almost forgot about that. Because look, -9 squared is equal to 81, and 9 squared is equal to 81, so it can be either or, right? Now, we would just want to bring this over to here, so w is going to be equal to 1/2 plus or minus 9. All right, so w is equal to -8.5, or it's equal to 10.5. Right, then you want to plug these two different w values into here. However, because this is a word problem, we can't have negative with, so just remove that shit. Now we have 10.5 times 2, right, which is going to be, I don't even know, 10.5 times 2, 21. 21 plus 2, so 23, and that's our length. Right, now we can plug that back in, right, and do 23 times 10.5, which, oh no, did I do something wrong? Oh no. You know what? It's fine. Just follow those steps, even though I might be wrong. Trust me, just follow those steps and you'll get the right answer. I have no clue why I didn't. Oh shit, I see where I went wrong. So instead of dividing by 2, I multiplied by 2. So just don't make that mistake. I'm too lazy to do all that work again, so just believe me, the answer's right. Okay, the next major one are maximize revenue word problems. Now these ones are, I'd say, the most trickiest, at least for me personally. But basically, this one is just there's a movie theater and they sell tickets for $5 and get 200 people coming. All right. Now you want to find revenue, right? So revenue is going to equal customers times price of tickets. All right. So price of tickets is $5, customers is 200. So that means the revenue would be what, 1,000. All right. Now we want to maximize revenue. However, for every 10 cents price increase, we lose 10 people, all right? So let's label that as price change, right? So we have a new variable called price change. Let's call it n, all right? Now n is how many price changes we make. So let's rewrite the formula, right? Revenue is equal to C, which is people, right? And we have 200 people, right? Then minus 10n, right? And what this essentially means, right, is that for every price change, right, we're going to multiply that amount of price, and then it's going to reduce it, right? Wow, that was really bad. So let's say we increase the price by 50 cents. That's 5 price changes, which means that 5 times 10 is going to be 50. We're going to lose 50 people. So it's going to be 150, right? Then we do the same for here. So it's going to be 5, and then plus 0.1n. And that's price changes. Now we just factor that out, make it look, put it into general form. I'm gonna just pause it and just do it off camera. Okay, there we go. Now this is the y-intercept and this all the other stuff, right? So now we will have to find the maximum. And because this opens downwards because it's negative, right? This point, that just proves that it's a maximum, all right? Now, you could do that by turning this entire thing into vertex form, completing the square, doing all that shit. However, that takes a lot of time, and there's a easier formula to do that. Right? Now, because you have your a and your b values, right? All you got to do is find for the p value. Now, p is equal to negative b over 2a. Now we just plug in those values, right? And then that's just going to be 30, because the negatives cancel out, over, oh, there's another negative. So it's going to be -2. So it's going to be -15 is the p value. Now p is technically like x, you know? So you just plug that. Oh, sorry. You just plug that as the n. You do all that, and then it'll give you the r, and that'll be your maximum revenue, right? And then, yeah. Sorry, I'm just really lazy right now, and I'm tired. But yeah, that should hopefully be everything. I'm gonna try a little bit harder in the next video. But yeah, bye.